exams, yeah, which or how operating system questions can be set. Okay, I think if we are able to try to test the kind of questions that appear in an operating system, we will be in a very good position to pass the coming exams. I'm also very aware that what we have been covering is more detailed compared to what is in is it the Longhorn book or the KLB? Yeah, or even both of them. Yeah, so it's been intense, and I know that at the end of this, and when you'll be attempting your exams, whether it is in the near future or in the end of your high school life, operating system will consist a good percentage of the exams. That is proof because the Form 4s currently today, right now, the Form 4s are doing their practical, which is paper 2. And paper 2, sorry, is paper, yes, paper 2. And paper 2 is entirely Form 2 work. Why I say it is entirely Form 2 work, because it is just applications, the MS Word, the PowerPoint, the Excel, the Access, the publication, okay? Now, when you look at these 5 applications, it is very easy to predict because we are sure of 3 out of 5 being attempted, sorry, being set, okay? Or even 4 out of 5 being set, maybe 2 questions being electives, okay? So if we start our Form 2 work early enough and we sharpen all the corners of the Form 2 work, that means before even you sit for the beginning to sit for the exam, that means we have passed paper 3, which will be the practical, which is usually Access as a small project, and paper 2, which is also entirely Form 2 work. So now the issue comes in here in paper 1. Because paper 1, I remember the last time we talked and we agree that it's usually around 12 to 15 topics. 12 to 15 topics. Or if the exam is a little bit tough, then it will be all the topics from Form 1 to Form 4, because now we will be examining all the Form 2 work, which is majorly practical, but now you will be the paper 1 will be testing the theoretical aspect of it. Yeah. Now, like for example, if we are tackling MS Word, yeah, just for example, there is a strong feature for MS Word which is called mail merging. Okay. Now, mail merging is a service that allows a user to be able to send multiple letters to multiple recipients. So the one letter to multiple recipients within the shortest time possible. Now, this is a practical exam. And I think it is maybe what has been said today, I have not seen, okay? So if you will be asked to list the mail merging procedure, which is usually 8 marks, that is the kind of questions that can be asked if it's theory. The other question can be asked the advantages of electronic, let's talk about the electronic spreadsheet of the traditional spreadsheets, the ledger books, the cash books, those are the kind of questions that you can be asked, okay? So the paper 1 is a challenge because of the amount of content that can be asked in that kind of, in that area, okay? So if we finish this Form 1 and then we get into Form 2, I think we should be able also, I've just been looking at some of your results in the computer studies, and it is, there's a big parity because some of you or some of us performed very, very well, and some of us performed very dismally. Yeah. Now I want to check and pick a paper and see the kind of questions which were challenging. Now, the kind of questions which were here are the same questions which are in the book. The only way or the only thing that has changed is that the details that you assume that cannot be set are the details that were set. Yeah, I'm looking at a question here, question number 9. Name the color used to identify USB ports for keyboards and mouse. Okay, now this is detailed. These are things you do every single day, but you assume. Okay, they might not be in the book directly, but they can easily be said. The other thing amazing about this question is that you were only required to write a color, and the color was going to earn you 2 marks. The question 2 also a color, sorry, part B also a color. It was going to earn you only 2 marks. That means out of writing 2 words, you have 4 marks. Okay, and we assumed much, and we assumed that. Okay, the kind of questions that we had been discussing, like the buffer, the main memory, I can see this person scored, but most of us still had issues. Okay, there's a question like question 12 that was asking you to match the left side and the right side of the appropriate. See, that question was very, very challenging a bit, but we could score a lot of marks because you had 5 options. We have CDR, read and write. We have jazz disk, we have memory, we have LS 120. So if you could only eliminate on this other side, depending on what category you're choosing, like let's say a CDR, a jazz disk, and an LS 120 are all removable devices. If you look from that angle, they're all removable devices. So if you gave a CD as a removable device, and then you don't pick it as optical device, you are still scoring. But now, when you come to the solid state and the jazz disk, you have really to be able to differentiate exactly. We can have a magnetic disk, we can have an optical disk, which is removable. You can have a solid state device, which is also removable. Okay, now these are the kind of questions that might not be directly you're expected to capture the content in class, but the explanations will lead you to be able to interpret that kind of question. Okay, so expect that kind of task, expect that kind of task. Number 19, cancel out the odd one out below. Floppy disk, flash disk, tape cassette, and zip disk. Okay, now some of us were striking out or canceling out the wrong answer in regards to the list. But when you look at what they were canceling and then maybe they were giving a small explanation, the answer was becoming right, because what could be struck out here is the is the flash disk, because it is more of a solid state. These other ones are magnetic disks. Okay. Now, when you strike out the tape cassette, okay, when you strike out the tape cassette and then you leave these other ones, and you explain that the tape cassette is used mostly for the radio and audio storage, you could score. So these kind of questions will always come. These kind of questions jog your memory. So you cannot just look at options or answers directly and pick without thinking. Okay, so we should and we will always be expected to think like that. Okay, I'm not seeing anything that could have brought issue. I'm not seeing anything that could have brought issue here. Okay. Marks were being gotten when you mentioned the 10 examples of application packages. These were 5 free marks. Yeah, because when you look at the computer software, all these things are listed. Okay. So expect this kind of questions. They are not going to be very direct as per the earlier one that you did for the term 1 opener, sorry, term 2, basically for term 1 end term. And then now again, we have differentiating between the parallel and serial interface. I think this one we tackled in the first session that we had. Okay, now we will be able to revise this paper. We'll be able to revise this paper maybe sometime next week. after maybe we finish what we want to talk about in the operating system today. Okay. Now, I want you to give me the answers. What was the question about the operating system last time, so that we see if we can proceed. Alan Kipkorir, Brian Mandu, Charles Mburu, Clinton Water. Can see you guys were up and early. Now I'll be rewarding the guys who come to class up and early and participate. I think I'll be giving you bundles, so I will see how it goes. Also, if you maybe I'm going to upload the videos on the YouTube channel for you to be able to review the classes and prepare for the next class. You subscribe, you view, just send me information, or you can just comment on the comment section, and I'll get your number and I'll send you something, because at least sometimes
name of channel.
Yes.
What's the name of the channel?
Okay, I will send in the group and then the other guys will share. Who's this guy called user?
Aaron.
I need you to rename yourself. Okay.
Yes.
Yes. And Aaron, I was still on you now. I want you to answer the question, the assignment that we had last time.
I'll define operating system, a role of operating system in terms of backup, and say that the operating system duplicates files and data which can be used in case the system data is deleted or maybe lost.
Up again.
I'd say that the operating system it duplicates some files and data which can be used in case the original data is deleted or lost.
Okay, what was the question?
So explain the role of operating system in terms of backups.
Okay, now okay, so okay, I've gotten your answer. Another try. I think it was not only in terms of backup, it was also maybe also the backup type. So Aaron, I want you to rename your name from user to the name I can recognize. Carlos Chelu Gets. Cesar Rabala, yes.
Excuse me, Malim. I tried searching, but I didn't find the first question, but I found a number of backups.
What backups did you find?
I found a full backup. I found incremental backup. I found differential backup. I found mirror backup. I found full computer backup. I found local backups. I found online backups, and I found cloud backups.
Now, which is the fourth backup you have talked about after differential?
A mirror backup.
Mirror, yes. Did you find something like dark backups?
Pardon?
Did you find something like dark backups or dark channel backups?
No, I did not.
Okay, so now explain to me the incremental backup.
The incremental backup is it's a backup of all changes made since the last backup. Okay. With incremental backups, one full backup is done first, and another subsequent backup are done. Okay. If I can, I'm not sure how to put, but it's one full backup is done first, and subsequent backup runs are made since the last backup. Subsequent backup runs are.
Or which are the intervals after what intervals does the incremental backup take place after doing the full backup? Is it set, or is it initiated? Like, is it scheduled or is it initiated, the incremental backup? Okay, as he tries, David Nyonji, Dalmas, Dudley, George. Now, I think I will remove you if I call your name twice or thrice and you don't respond in either way. I will remove you. So I want you to stay active. Lee Wanyanga. Lee Wanyanga. Okay, so I'll come back to that. Elvis, you're saying something. Do you have your audio on? I see you here. You're saying about the application areas of batch processing. I remember talking about that earlier. Elvis, I need your audio. I need you to chat to everyone. Don't chat to me, so that we can be able to contribute to that. Okay. Lee Wanyanga. Okay, Michael Makunyi. Michael. Emmanuel Hamadi. Emmanuel Hamadi. Okay. Onil Rabi. I want you to tell me your contribution, your findings. Onil. Okay. So I'm easily detecting the people who are there but just have gone out. Ngoto Josiah. Ngoto Josiah.
Yes.
Yes. Contribute to the topic, to the assignment.
Last lesson I wasn't there.
What do you mean you are not there? So you did not need to find out.
I asked.
Okay, so give me the answers. Okay, find out. Oscar Mau.
Yes.
Yes, sema kitu. Oscar Mau. Okay, I'm moving you out. Brian Maundu. Brian Maundu.
Yes, for me, I found that backup is the process of replicating and backing up all selected data and end devices and network nodes into a single computer.
Okay, what's the role of the operating system in that?
I found that it backs up all configurations of files.
Okay, yeah, that's very true. Matthew Sydney, give us a contribution in terms of the application of the batch operating system.
I found out that the batch operating system uses batch processing.
Yes.
Where it's a method of running high volume and repetitive data.
Okay, yeah, that's true. That's very, very true. Now, I want you guys to really contribute because it is expected of you. It is expected of you in terms of the agreement of studying as well. It has been studied that the more you contribute, the more you will be able to retain the data in your memory. Okay, so let's proceed and wind up the operating system, the operating system type. So last time we looked at the network operating system. Today we look at the real-time operating system. Now you should be in a position to differentiate. Yeah, you should be in a position to differentiate, relate, compare, and do all those other things when it comes to in an exam. Okay, because if I will ask you, explain. I give an example that we have the batch operating system. okay? List 4 others, as well as their disadvantages, advantages, application areas, and examples. Yeah, that's a question that can earn you up to 16 marks, because when you list is 1 mark and I need 4 of them, that's 4 marks. When you explain is 1 mark and I need 4 of them, that's another 4 marks. Okay, when you give the application areas of each, that's 4 of them, that's 12. Give examples of each, that's 4 of them, that's 16. So it can go as deep up to 20 marks in consideration to the kind of information that is required. Okay. Now I hope you can see my screen. So usually, as usual, as we do this, we go through it and we shade that and we do that. Okay. Now the real-time operating system is defined as a data processing system in which the time interval required to process and respond to inputs is so small that it controls the environment, okay? So the time taken by the system to respond to an input and display of required updated information is termed as the response time, okay? Now, look at this. What is determining the real-time operating system basically here is the response time. Now, real-time means I do it now, the changes reflect immediately. The other time we're giving an example of this distributed system where we have a bank account, and this bank account is being operated by individuals in different parts of the country or different branches. So what happens is that once the transactions are initiated, they are expected to reflect in a particular account within some stipulated amount of time, okay? But in this case, the real-time operating system, whenever we do a transaction usually is an instance or an activity that is done on a database, okay? So when it is done on the database, then it is expected to update the database immediately, okay? Now, the operating system comes in because it manages all those requests. It provides a response to all those activities which are expected to be performed by the processor, okay? So the real time here, the response time is what comes in handy, okay? The shorter the response time, actually the immediate the response time, the more the system qualifies to be the real-time operating system, okay? Now let's look at how it is used. So the real-time systems are used when there are rigid time requirements on the operation of a processor, okay? Or the flow of data and the real-time systems can be used as a control device in a dedicated application, okay? Now, what this means is that whenever we have very little timelines onto how we need data to be consistent, okay? We need data to be consistent in a pool, then the real-time operating system comes in handy, okay? Now we have a real-time operating system must have well-defined fixed time constraints, otherwise the system will fail. This is a scenario, for example, let's talk about a company like maybe for Safaricom. You load data or you load airtime, okay? The way we always do, we load data or you load airtime. But it takes a lot of time for the data to reflect in your device, as well as the airtime to reflect on your number, okay? So this is a disadvantage. It's a major or it's a big disadvantage because the quality of time, the quality of the constraint, and also the quality of time availability of the resource is not achieved. I want to join the class at 10 a.m. I buy data bundles at 9:50. By 10:15, it has not reflected the class is on. By 10:30, it has not reflected. Then by maybe 11 o'clock is when you realize your balance is reflecting. See, now the quality of availability and the quality and the time essence has now been beaten out of this, okay? Let's look at this. For example, scientific experiments, medical imaging systems, industrial controls, this. Now, these are items, or these are basically systems that require immediate response whenever feedback has been given. They require immediate response whenever feedback has been given, okay? So this means that if we, let's look at a weapon system, a weapon control system, yeah? You initiate a weapon control system, or you send a missile, but you realize at the end of it, or at the middle of it, it is not heading to the right direction. By the time you try to recall the operation, you try to recall the system, it has already, damage has been done. The air control system, the air traffic controls, these are supposed to be real time. You give an instruction now, immediately it responds to, sorry, the instruction is executed and the response is felt, okay? Also, the system industrial control processes, scientific segments, medical imaging systems. So we expect those ones not to be batch processes. Sawa. Let's look at what we have as the examples of real-time operating system. Usually there are two types. Yeah. So they say hard real-time systems, that's one. The other one is a soft real-time system. So let's do that to this, and then let's do this, and let's do that, and then let's see now hard real-time system. So this hard real-time system guarantee that critical tasks complete on time. In hard real-time system, secondary storage is limited or missing, and the data is stored in the ROM. Okay. Now look at this. The aspect, or what is differentiating this, one of them is the time on which the task takes to get completed. Okay. Secondly is where the storage is taking place. Okay. Thirdly is the virtuality of the memory, if it is found or not. Okay. So the first one says hard real-time systems guarantee the critical tasks complete in time. Okay. In these systems, secondary storage is limited or missing. Secondary storage is limited or missing. So this means that where these instructions can be stored is basically in the primary memory. Okay. So when you look at that, those are the differentiating factors. Okay. Secondly, the soft real-time system. Okay. Soft real-time systems are less restrictive. A critical real-time task gets priority over other tasks and retains the priority until it completes. I remember when you were talking about the scheduling, I talked about the priority aspect where we have system requirements, we have user requirements, and then we have the application requirements. Okay. Now, when you look at all these three aspects, there must be one which is given priority. Yeah, there must be one which is given very high priority. Okay, very high priority because of the impact that it has on the system, the impact that it has on the operating system, the impact that it has on the general operations of the device or even of the system also. Okay, so look at this. The hard-time real system guarantees that critical tasks are completed in time, okay? But in the soft real-time, the critical tasks are given priority. And once they have been given this priority, that priority is retained. They keep that priority until it runs to completion, okay? So more on that, we say soft real-time systems have limited utility than hard real-time systems. For example, look at this: multimedia, virtual reality, advanced scientific projects, okay, like undersea exploration. Okay, now what you mean when you say it has limited utility than hard real-time systems is that they possess system services, they possess the system requirements only when they need those tasks, okay, to be performed in priority. Okay, but in the hard real-time systems, they can have the virtual memory and all the other real-time systems viewed up to conclusion. Okay, so we have again this. we have again, yes. So that is, I think that should be the last thing on the operating system types. So we should be able to answer the questions that come in that aspect. Okay. Now I need you to have the questions next to you. You can write them down. You can write them in the chat section, or you raise your hand for us to be able to address it. Okay. So any question in terms of the real-time operating system, the network operating system, the distributed operating system, the time-sharing operating system, the batch sharing operating system. Yeah. Any questions? Any question? So does that mean you have understood very, very well? Okay, I still need to speak to this guy. This person is called Liwanyaga. Liwanyaga.
Yes.
Yes. What happened? You left and you returned.
I know there was some issues with the internet for a while.
There was no issue. I'm the one who removed you because I was asking questions and you were not there. You put your audio off, your video off, and then you left.
No, it was there, but then sound took a while for it to come to my end.
Okay, now tell me.
That's why.
Okay, now tell me.
Yes.
Yeah. What was the question that we had last time?
Not too sure. That one.
Yes.
I'm not sure. I'm not sure.
What do you mean you're not sure? Why are you not sure? I will remove you again because you cannot be here and you're not sure why you're here.
I didn't hear the question either.
When did you not hear the question? Today? Yeah.
No, sir.
Yeah, I need you to participate. I need you to participate. Okay. Now,
Okay.
but you know what batch processing is?
Batch processing.
Yes, the batch operating system, how it works.
No, I'm not sure it works.
I can't hear you.
I'm not sure how it works.
Kijana, utatolewa kwa hii class. Hiyo sana. So I want you to look at them because now these are the kind of questions that I will be setting or will be set in the exam, and I expect you to answer. Randy Myers, your hand was up. The people sending question in the direct message, I will not answer. I want you to send the message to everyone so that we are able to see the question. Okay. Randy Myers, your hand was up, and then there was also someone else before we move on to the services of the operating system.
Pardon me for interrupting you.
Yes.
The chat section is only allowing us to chat with you specifically. That's why there's no option of sending to everyone.
Okay, let me check. So. Just a minute. That thing, that this means that I'm supposed to stop it, and then anyway, so I'll be sending just send directly. That means I'll need to end the session and go to the settings and do that again. That might take time. Okay, so I will read them, but some seem ridiculing. Someone is asking what is a computer. This one should be removed. This one I'm going to remove. That is Zach. Valentine is asking, is time sharing operating system the same as multitasking operating system? Is time sharing operating system, or let me copy this. Is time sharing the same as multitasking? So I think everyone will be able to see that. So there's that question. There's no other question. There are some responses which I had talked about now. What is time sharing? And what is multitasking? So that we see if they are the same. I remember sending some material on time sharing. So I want you to give me the difference. Yes, Nick Kimapi.
System
Only.
is basically a system that allows many people located at different positions to access assist particular at the same time. And we gave an example with the transactions, the banking transaction, the money transaction, and how they work with the same system for different people at different locations.
That is for time sharing.
Yes.
But that seems more of distributed. Okay, I remember talking about the time sharing. That is true. That's it. That's true. Yes. And what about the multitasking?
I remember when we were talking about the time sharing operating system, we included some concept of multitasking, but I'm not sure whether we see that we can also call it multitasking, but there's that concept of enabling it to perform various tasks, and I think we related it to its name, time sharing.
Okay, now your attempts are correct. Your attempts are very correct, and the question is very valid also, because time sharing and multitasking go hand in hand. But when you look at the environment in which they thrive, is a time sharing one thrives mostly in a network environment, while the other one exists more in a PC or in like a standalone system. Okay, so when you talk about the multitasking operating system, it is an operating system that can perform a number of tasks at the same time. Okay, like the ones we have. Okay, yeah. So if it is a single PC seated on a workstation or a single node, qualifies for that. But the real-time operating system, real-time systems, we have various individuals on various locations. So basically, that is the difference. Okay. Okay, let's see another question. I don't have another question. Zach is asking, what is a computer? Zach?
Excuse me, sir.
Yes.
So when you were describing time sharing, that it is able to run at, it enable to allow many people to use a computer from different places. Then what is distributive OCS?
Now in the distributed OCS, what's distributed OCS? What does the OCS stand for?
Oh, I meant operating system, OS.
Okay, now the operating system for the distributed operating system, just as the name suggests, there is distribution of their operating system functions. Okay, now we can have a branch in Kikuyu. Maybe let's go to Equity, yeah. And then you have another branch, maybe in Kino, in Nairobi, okay. And then we have now the main server, okay. Now, basically, when you talk about distribution of the operating system, means that it gives us the ability to be able to accept information, distribute resources to various locations or from various servers. Okay, now we might have the big server, and then we might have a server in a banking hall, one banking hall in Kikuyu, another in Nairobi. Now, when all these banks, or when all the server or all these network operating systems work together, we might be able to enjoy the ability of them being able to just receive all the information from all the other branches without the user realizing that they are coming from different locations. Because when a transaction is done in particular branches, now all the transaction which has been done is updated in the bigger server. Okay, so this I think I can have an example here, but this is about databases. So let me look for this diagram. Yes, so let me share this so that I can use it to explain. But it's about databases. Okay. Share. Okay, now this is something I was looking at yesterday. Okay, the database classifications, and this is basically, this is a server. Yeah, I think you can see. Let me move that. So this is a server, okay, on this other side, okay, on the right side of the screen. Now this is a server for a branch. This is another server for the branch, okay. Now the transactions that happen here are totally independent, but all of them are loaded inside here. Now this is the best aspect of a server distributed operating system, because once the distribution of services are done on this server and the other one on this other server, and it is able to reflect on this node, on any other node, whether mobile phone or any other workstation, then basically once we upload all the transactions on the central server, no one will realize that they were brought from this one and or from this one. But in the real-time operating system, in the time-sharing operating system, on this other side where they have the centralized database, okay, where we have the centralized database, okay, this means that when every individual wants to update, see this, let's take these 3 laptops as 3 nodes. One is mobile phone, the other one is ATM machine, the other one is a teller machine, okay? So anything that they do are updated on the single server, okay? So I think, Valentine, with this illustration, we should be in a position to understand. Have you looked at it closely so that we be able to know the difference between the time sharing and the distributed? The distributed means that there are servers at different points, while on the time sharing means that there are no servers at different points. It's just a single server where everything is loaded there. But for distributed, ziko tofauti ambazo zinafanya kazi ya load kwa the major one at the end of a transaction, or even at the end of they're basically an instance, okay? So when you look at this, then we should find it very easy to, when you look at, stop sharing this one. When you look at that, you find it very easy to come and understand the time sharing and the other operating system, okay? Okay, another question here. Multitasking same as, okay, that's mine. Do distributed is time sharing same? That is what Shadrach Tamani was asking. Distributed OS and time sharing relate in terms of multitasking? Yes, they do. Yes, they do. Yes, they do. Yes, they do. Very well. Then we have some questions here which I don't expect us to have. Someone answer this one. What is the difference between multitasking and multiprocessing? Okay. And then there are some questions here also. Sorry. There's another question here. So I'm sending them because I don't want to stop the session and go to the settings and reset the chat section. Okay. Okay, we have those 3. Hii ya kwanza tumeanza, do distributed, which is okay. The second one, oh no, this ones have been replying to Shadrach. What's happening? Okay, can I attempt that one? What is the difference between that? Okay, so Now, some of the questions are questions that I don't expect us to ask, because they are what we have been doing the whole of last term. Like, what's the difference between, I think this is OS and system unit? There's a reason why we calling what you said as a system unit. There's what we used to call it before. We used to call it the CPU, and I said it is not called the CPU. The CPU and the system unit are totally different. Yeah, because of the components and their functions. Okay. Someone is asking something here. Randomize is asking, can we also say that batch processing is used in processing tasks? That is very, very true, because task is processed at the end of a financial year, or at the end of anything, like maybe a payroll system or something like that. I see your questions are okay. I think I've answered, but some are wanting, because this tells us, or tells me, that we were not concentrating in most of the sessions. Okay, so there we go. So we are now on the operating system services. So we should be able now to understand what are the operating system services, but they might be close to the functions of the operating system. But when you look at this, some will call them the services, some will call them the functions, but they should be the same. Okay. An operating system provides services to both the users and the programs. This is basically the services. Now, every time when I was talking about the operating system, the processor, I was mentioning the term resources. Resources are how do you call it? Sorry about that. And the operating system is a resource by itself. The processor is a resource by itself. The storages are resources which are supposed to be provided to the processes on request. And we realize that there are three key factors when services, or when operations, or when processes are being performed. The first one is the availability of the resource. And then there is allocation of the resource. Okay. And then there was deallocation or reallocation of the resource. When it came to memory management, input, output, device management, all those kinds of management, all those resources have to be managed. Okay. Now let's look at the services that are provided by the operating system. Okay. Now, program execution is a service. Okay. But it is not in the functions of the operating system. Okay, so find a way that you will be able to differentiate between the services provided by the operating system and the functions of the operating system. Okay, now we had file management, but here we have file system manipulation. All those are covered here. All those are covered here. Okay, now let's start with this. So all this is let's do it again. Yes, so all of this, we're going to tackle them here, and we're going to explain them. I will forward this document. I will share it to you so that we will be able to look at it, and you will be able to use it. Okay, so the operating systems. So let's look at the first one, which is the program execution. So operating systems handle many kinds of activities, user programs, as well as system programs like printer spooler. Yeah, I remember mentioning about the spooler, where we talked about a multi-processing or a multitasking operating system, where you have 3-4 functions to be performed. We are printing, we are listening to music, we are typing, and then we need priority on printing. So the spooler is the one that will detect, or that will determine, the priority in terms of printing, and also is going to to schedule the printing jobs, okay? Naming of servers, file servers, etc. Now, this, the content in this require us to be able to comprehend a lot, okay? To be able to comprehend a lot and make it easy for us to go through them slowly so that we find the differences between the functions of the operating system as well as the services. So here we say a process includes the complete execution context, okay? The complete execution context. So when you talk about a process, this means that this process needs to be completely executed, okay? Now, there are stages on which processes, that processes follow from the beginning to the full execution. First of all, the instruction is fetched, which is the role of the operating system in conjunction with the main memory. Once it has been fetched, it's supposed to be executed. Okay, so here is where we get the executed, and then is manipulated. The registers, you know, the registers are here. You used to say that they are fast, short temporary memories, which they are still, yeah, and which operating system resource is in use. So let's look at the major activities which happen in the program execution. Yeah, the major activities which happen in the program execution. Okay, now the first one is loading the program into the memory. Okay, loading the program into the memory. This is basically preparation of the program for execution, because execution instructions are supposed to be residing in the memory. So anytime we have execution of instructions into the memory, then that should be the first step when it comes to program execution. From that point is when now the operating system starts to collect the resources which are required for this program or for this instruction to be executed to completion. Okay, so this will mean that anytime we want to perform a process, or anytime we give a request to the processor, okay, so that will ensure that the processor and the operating system, as well as all the other system requirements, are collected to prepare for the execution of this program. Okay, the first resource is the memory. This one, okay. So I'm going to write the resources next to them, which are responsible for that particular one. So loading of the program into the memory. This is the memory, but we can be specific and talk about, there are those kind of resources that we were using when it comes to, it holds the instructions, where it holds the address to the next instructions. So this is basically the register holding the address to the next instruction to be performed. And then there's another one which was saying that we hold the instructions to the ones, so we hold the address to the ones which have just been performed. Okay, let's see. The next one is the execution of the program. Okay, but the resource which is responsible for this is the processor. Very, very true. Okay, and then handles the program execution. Still is the processor. Yeah, so here that and that is the processor. Okay, so let's bring this one here. Okay, provides a mechanism for process synchronization. This is the operating system. This is the operating system. Provides mechanism for process communication. This is the operating system because of the communication management and the file management. So the OS still is there. And then provides mechanism for deadlock handling still is the operating system. Okay, so you see, out of the roles of or the program execution, you see the operating system is playing a very big role because of the importance of it in terms of that. So up to here, The first three, you can see the memory is involved because of the RAM. Sorry, because of the ROM and the RAM when it comes to the loading into processor. And then we have the execution of the program, which is the processor. We have the handling of the program execution, again, which is the processor, provides mechanism of process synchronization, operating system, and the deadlock handling is the operating system, okay? You have been having this question, I know, in the past papers, yeah? That one, okay, let's italize it, and then let's move it and align it, okay? What is a deadlock? What is a deadlock in terms of operating system? What is a deadlock? So that you see what you mean when you say deadlock handling. What is a deadlock? Eugene Mukui? Joel Peter? Eugene Mukui?
I think it's when maybe the computer is hanging, so you cannot really do the processes.
What do you mean you say computer is hanging?
You have no access to something you want.
Is hanging supposed to be the term? Anyway, your response is not correct. So I need another try. It's not another try. Aaron Yongesa, your hand was up. Yes. What's a deadlock?
Deadlock is, this is when two processes using the same resource block themselves, waiting for the other process to take action, and none is willing to relinquish its resource.
For example? Wangoliko.
For example,
yes.
Maybe I was, for example, maybe I'm downloading a game, and then maybe something else comes up that also I want to download. Then it reaches a point where both stop and they just pause.
So why do you think they have stopped?
Maybe they are exhausting the resource because they're using one resource.
Another try. It's close to a very good scenario. Brian Monzia, what is a deadlock? Tom Keegan, Alan, Eugene, Brian Monzia.
Yes.
Yes. What is a deadlock?
A deadlock is some kind of traffic which is experienced in a computer in a circumstance that the computer is having many processes, thus it cannot some more processes cannot be introduced or accomplished.
Okay, did you listen to Aaron's statement?
Yes.
What did he say?
He said that he gave an example. For example, is downloading a game, and then some other, for example, a notification pops up of another application which needs to be installed, and then they both bring a fault and the downloading is paused.
Okay, so that is exactly what a deadlock is, where now the resources are, maybe when you assign resources, you assign sections or parts of the resources. So this means that we expect one service or one process to release, whatever service it has, so that it can lead to completion of the other service. Now, so what do we mean when we talk about Deadlock handling. What do you mean when you say deadlock handling? Rodney, Wayne, Karegi, Wayne Omondi. Jackson Gugi. Hey, Ibrahim Hooker. I agreed if I call your name 2 or 3 times, I'll just remove you. Wayne Omondi. Wayne Karegi. Okay. Johnson Bogo, what do you understand by the term? What do you understand by the term deadlock? Roy Hillary, you're next. Johnson Bogo.
Yes.
Yes. What do you understand by the term deadlock?
It is when a system is waiting for another system to operate before it starts its own.
Huh?
It's when a process is in a waiting stage for another process to complete.
But
it cannot complete because they are using the same resource.
So how is deadlock handled, or who handles deadlock? Roy Hillary, who handles deadlock? Roy, is this Khatolwa? Roy Hillary, who handles deadlocks? Okay, so I can't see any question on the chat, and I need you guys to, let's proceed. We have the input-output operation. Now, I have explained this one so well, and must say that I'm not impressed by how you have responded to that. I expect you to be very, very keen when you're doing the explanations. And I know the deadlock handling has been an issue, and it has been a question that is usually repeated because students overlook it and do not explain it very, very well. That is why I wanted us to look at it. Let's look at the other service. Okay, the other one is the input-output operation. So this is subsystem that comprises of input-output devices and their corresponding driver software. Okay, so drivers hide the peculiarities of that. Now, this is mostly explaining or mostly talking about the drivers. Okay, and the other time we mentioned the drivers, we realize that it's a small piece of code that come with the devices, which enable the devices to work very, very well, okay? And they work in conjunction with the operating system, okay? That is why here we talk about the subsystem, yeah. And the subsystem, since it's close to functioning as the operating system, then at the end of the day, it looks like that particular physical devices management operating system kind of, okay? So we need to understand that, okay? So let's say this one, input-output operation means read and write or write operation with any file or any specific input-output devices. So this is more direct. There are no factors like this, like the ones that allow the major activities to take place in a program execution. Okay, so the other service is the file system manipulation. Now I'm going very, very slow in terms of this because I don't want you to confuse the services of the operating system with the functions of the operating system. The services of the operating system and the functions of the operating system. Okay, so the file system operation manipulation has this as a service. So a file represents a collection of related information. So computers can store files there, secondary, primary, CDs, that one. Okay, so here a file system is normally organized into directories. Okay, so once a file system is implemented, usually is arranged or organized into directories. Okay, directories are like folders or directions where, or locations, sorry, where the files are stored, as well as the directions where those files are stored. That is why sometimes you see something like it is not covered there. So let's look at let me give you an example of a directory. Usually called a root directory, a path. So we want to have this diagram, or we want to have this again, sorry, we have this file which is in the hard disk. Which is in the hard disk, and then correct that later. And then it is in a folder called system files, which and then inside the system files we have program files, and then we have in the program files, let's have compilers, and then in the compilers let's have tasks. What's happening? Tasks, and then in the tasks let's have maybe hello world. Okay, so now this is an example of a file. We know the name of the file, we know where it resides, as well we know the name of the file. Okay, now this hello world can be of, let's say, MS Word. So I'm trying to create a directory. This is a file direction. Okay, so this means in the hard disk you're going to find something like the hard disk usually drives C, so usually it's a C dot, sorry, and then we have the name of the file, say system files. Okay, that's program files. That, and then we have compilers, and then we have tasks, okay, and then we have hello world dot doc. See, this should not be there. Okay, dot doc. So basically that. Now this is something called the root directory. Okay, you can have this here. Yeah, this. So this, if you type this, if you're using the graphical, if you're using the MS-DOS or using this other GUI, the command line. So you just type this onto the search, or you just type it onto your window, yeah, and then this file will appear. these files appear, okay? Because we have folder, 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 and then the file whose nature is that, okay? So this is basically what you mean. Now, usually in the, when you're using Windows, okay? When you're using Windows, you will realize that they will appear. Let me see if I can move this. No, it's not possible. So, but if you can see here, you see I'm using a Google document. Yeah, I'm using MS Word on the Google Drive. Okay, so this tells us that this is a .google.com, where that is like the root. That is where this file is stored. Okay, let me just copy it so that we can discuss it. So using Google Drive, it's cloud storage, and then yeah, let's do that formatting. You see, good. So this HTTPS just tells us that the file is on the internet, and then the doc.google there. This is like the roots, like that is like the file, the major file where the file is stored. Then we have the document part, which is also a file. Then this is like the code to the file that I'm using. So it is on edit because I'm editing it. I always keep editing it. So whenever I edit, you will see this cloud here, this one. Yeah, you will see it ticking, saying saving or saved, which will tell us the document status as per when I'm working with it. Okay, so if this file was in a hard disk, so hapa ungepata ingetoka ikuwe http, ama maybe ingekuwa kwa drive ama iko kwa flash disk, ningesema E or F, yeah, or if it is on a partitioned device, ningesema D. Okay, so this is basically what we mean talk about file management. Okay, this is what we say a file system is normally organized into directories for easy navigation. Okay, so these are the directories. So the root directory is the hard disk, which is this one. So this is called a root path. The whole of this is called a path. So when you'll be asked for the path of the file, this is what you will write. So this is the path of my file. So if I want to share with you this document, if I want to share with you this document, let me just share with you this document right now in the chat section, so that you see how you will be able to access it via my Google Docs. So if I copy, then let me go to the chat section, then I chat. So I was jumping around over the chat. I'm going to remove them. Just give me a moment. Okay, so I want you to follow that. So you can copy it and paste it in your browsers, and then you'll be able to see it. Okay, so just let me share it once I'm done, ndio tuweze access vizuri. Okay, ndio tuweze access vizuri kabisa. Okay, so that is that. So let me check on this crook, then remove them. So that's done. Okay. The following are the major activities in the operating system when it comes to file management. So let's move this to the new page. The program needs to read a file and write a file. So that is basically the rights that we give the file through the operating system. We give them the read and write rights, which are the read and write abilities. Thank you. Okay. And then the next one is the operating system gives the permission to the program for operation on file. Okay. So permissions vary from read only, read write, denied, and so on. I know when you're using MS Word in some of the devices in our lab, you usually get this, where or maybe you download a file or you access a file and then you're told that this file is read only. So that is basically what you mean when you talk about file management. We make sure that we restrict the unauthorized users from using that, okay? Then we have operating system provides an interface to the user to create and delete files. That is very, very true. Again, files, again, operating system provides an interface to the users to create or delete directories, which is also okay, okay? And then lastly, the operating system provides an interface to create the backup of file system, okay? Now, note those, we have to take very good care of those terms because now those are what dictate how the file system manipulation processes advance or how they are executed, okay? Another service is communication. Now, I know you have realized that today's class is not very lively and loud because of the details. I don't want to change the tone and eliminate the importance of any of the content you're handling. All of them are of great importance. So today we are like this because I want us to find a very clear distinction between the functions of the operating system and the services of the operating system, okay? The functions of the operating system, last time we realized that there were around 10, more than 10, and here now we have like 7, okay? So if a question is set that requires 2 marks per point, and you just, instead of looking at the services, you give the functions, then you have lost a lot of marks, okay? So let's be very, very keen on this, okay? Let's look at the communication. So here, they're bringing us back to the in case of a distributed system, okay? Now, someone had asked a question about this. Let's see if this is going to shed more light. So let's punctuate it like that. So we say that in case of distributed systems, which are a collection, of processors that do not share memory, peripheral devices, or a clock, the operating system manages communication between all the processes, okay? In case of a distributed system, okay? We had said that this distributed system is like we have these devices on branches. We have these devices in different sections where the update is done on those particular branches, and then it is reflected on the central server. So that is why we are talking about not sharing memory, not sharing peripheral devices, clocks, or operating or clocks rather. Okay, so the operating system is what will manage the communications between all these processes. So the central server is what will manage all the operations between these other servers, which are in turn managing operations between the devices which are under those local servers in those particular branches. Okay. Okay. Okay, let's proceed. Okay, so multi-process multiple processes communicate with one another through communication lines, okay? Now, when you talk about communication or the communication lines, we mean that these are just medias of communication, okay? Some people will talk about communication lines, some people will talk about telephone lines, okay? Telephone lines are kind of cables which are used to transfer data, maybe the faxing and the audio, okay? So that should not worry you much. Nick, I'm seeing your hand up, so maybe if it's urgent, you can talk about it before we proceed to the major activities.
Yes, I wanted to have on the deadlock and the mechanism for the deadlock.
Okay. Okay, so.
Let's say if the reason why the program cannot access the resource because it does not have the required security credentials or licenses in order to access it. Maybe it has a password or a lock or something. So maybe this deadlock unlocking mechanism or software has the required licenses or credentials, a sort of a pass to allow the program to access the resource, and in that way it unlocks the deadlock.
So you're talking about how the deadlock is resolved.
Yes.
Okay. I've had your point. When you talk about the key or the access mechanism, are these services of the same nature? Like, are they both, if you maybe the way Aaron had talked about downloading, are they both of the same nature? Are they both downloading activities, or others are different process executions?
I'm not sure necessarily whether they are the same activities, but concerning the deadlock unlocking mechanism, that's the idea I had of the unlocking the deadlock through required security credentials and licenses that can maybe issue some sort of pass to allow the programs to continue running.
Okay, but basically, who sorts the deadlock is the operating system, in terms of sometimes it just kicks them out of the waiting tray in terms of the resources that they're consuming and the functions that they're denying. Basically that, and also others is it informs the administrator about that. Also the how do you call it, the network administrator or the individual user, it will inform you about that the following systems are taking long to respond. Would you wish to stop it now, later, or wait? So it gives you that information when that time comes. Okay, and this majorly happens when the memory is crowded, or when the memory is let's say there's a lot of, or the memory is small. Okay, maybe we have given it a lot of tasks to execute, or we have also now just little memory. Okay, Joel Peter.
Yes.
Excuse me, teacher.
Yes.
There are some situations whereby some apps say, like WhatsApp, it says application is not responding. Do you want to close the app?
Yes.
Is that an example of deadlock and how
That
it's
is an
resolved?
example of a deadlock.
Thank you.
Yes, that might be an example of a deadlock or a processor issue. Okay, but if you have a processor issue or RAM issue, okay, because usually if you stop it, then it will come and function again, because at the back of the processing or at the back of the memory functionalities, there were some priority processes which denied that program that service. That is why it stopped to respond. Okay, so we have this, which say two processes often require data to be transferred between them. So these are the major activities. So let's bullet them and see how many they are. So two processes often require data to be transferred between them. That might cause the communication errors. Two, both processes can be on one computer or on different computers, but are connected through a network. Okay, so this is communication on how the information is going to arrive to the processor in terms of process completion or status in any way. And then the next one is communication may be implemented by two methods, either by shared memory or by message passing. Okay, so when we are handling this kind of processes, we really need to ensure that communication is very key in regardless to those activities. Okay, you can see we are no time bad, but I need you to look onto these three. So have this task. According to the Services of the operating system, write it down. According to the services of the operating system. According to the services of the operating system. Highlight. Highlight. And compare. Highlight and compare on error handling, resource management, error handling, resource management. Highlight on the error handling, resource management, and protection. Highlight on those and protection. On the side, highlight on those, comparing them to their counterparts, comparing them to their counterparts in the functions of the operating system. Comparing them to their counterparts. Comparing them to their counterparts in the functions of the operating system. Comparing them to their counterparts in the functions of the operating system. Comparing them to their counterparts in the functions of the operating systems. Comparing them to their counterparts on the functions of the operating system. So we will address that, and then we'll look at questions that we'll revise the paper a bit, or look at another past paper which might be sent to you early. You will need, I will upload the content on the YouTube, and then I will want you to view them, and I will reward airtime, the bundles rather, to the people who will view and comment, or maybe share and subscribe, so that we make sure that everyone enjoys the aspect of the recordings. Okay. Aaron Nyongesa?
So you said error handling, resource management,
and protection. And protection.
Okay.
Okay. So you guys go have a nice day, and then see you some other time.